Hey everyone, Nick Como here, co-founder of aiquery.io, coming at you with yet another quick use case. So you may have seen the prior video where we talked about LiveShell for Linux. Today we're going to talk about LiveShell for Windows. Very similar in their base capabilities and the interactive nature of the shell. The primary difference is the base interpreter being leveraged. So on Mac and Linux it's Bash, on Windows it's PowerShell, which is pretty cool because you can utilize some PowerShell commandlets like write and line. So we'll showcase that, but instead of just showcasing a feature, we want to give kind of a backstory and use case to go with it. So this is kind of building off the original demo, which is up on our website. If you haven't seen it, highly recommend checking it out. Again, aiquery.io. But the brief synopsis is basically saw some unusual activity coming from our EC2 Windows Server machine. We investigated that. We saw a odd user that we weren't aware of, verbal kint, which, if you know, it's Kaiser Sose. But before we go ahead and clean up and remove that user, we want to make sure there aren't other potential persistence mechanisms so they can regain a foothold in the environment once we kick them out. So that's where we're going to use AI to help us craft a query. So what we're going to want to do here is under the mode, we're going to utilize the attack mode this time. And then in the sub mode, we're going to specify technique ID, which is based off MITRE's TIDs. I'll circle back to that in just one moment. We want T1547.00, and say registry, and we'll generate. So while that's going, MITRE TIDs, if you're not familiar, you can click the link, check it out. Basically, they're tactics and techniques that an attacker or adversary might utilize in your environment to do things like reconnaissance or gain initial access or execute their payload or gain persistence. So OS Query inherently is not able to identify all of the TIDs, but it can be very useful in the event of a potential breach that you're identifying, say from your network or your endpoint or your EDR tool. Then go ahead and spot check specific technique IDs that otherwise may be missed within your tool with AI query. So you can obviously just specify the actual name. This one we're using T1547, which is boot or logon auto start execution. So once we wipe the machine and reboot it, we want to make sure there isn't persistence mechanisms, right? But for whatever reason, numbers work better in my head, so I just remember the TIDs rather than their names. But this is a basic example of how you can utilize this, and this kind of goes across the board. Now we should have a result, which we do, which is excellent, but just to kind of round off the mode discussion. So in the original video, we talked about Windows Event Log. And again, modes are more meant for specifically designed use cases. If you don't know, just use general. But if you did have a specific inkling of something you wanted to search for, utilize a mode, get higher fidelity in your responses. So we talked about technique ID, which is a useful one. But if you weren't sure about a specific tactic you're looking for, you just know a certain type of attack, let's say APT29, you could specify that with group or name. Or if you're more looking for binary-centric characteristics like Mimikatz or SolarWinds, you can use Yara. But with that said, let's get back into it. So here we have a query generated for registry. We can see that it's actually looking for the current run or the run path, right? Run once for current user and for local machine. For the sake of the demo, I only have it under local machine. And current user, you'd actually need to specify the user SID or wildcard out the user SID. But we'll just leave that for now, hit accept, and go ahead and execute our query. Once again, you can actually see right here the confidence variable of what's generated from AI, because sometimes it'll try and fit the use case you're asking, but maybe it can't entirely do it, and this is a good indicator of that. But with that said, let's pivot on over, check out the results, and here we can see we have one result with a warning. So the warning is almost certainly because the registry hive requires a user SID. If you didn't know, you could always hit analyze error, use AI to kind of help you out and identify what the error is, and then immediately edit the query from there. But we know what the issue is here. That's fine. We got what we're looking for right here with the path being the run and Kaiser Sose, the name being Kaiser Sose. And then we can see here in the data that it's changing the PowerShell execution policy to unrestricted. And it is also calling a file called bad.ps1 in a hidden recycling bin within the C drive. So obviously not great, and now we're going to want to do something about it. And this is where we pivot into LiveShell. So we'll go on over and we'll click on LiveShell here. We'll select our device of the EC2 WinServe, and then we'll hit continue. All right, and here we are within the LiveShell, which is excellent. So as you can see, we're remoted into the machine. This is the path that we're in, and then the user or the PowerShell is what we're leveraging. So we can do who am I, check out user real quick, and we can see we're system, which is great. So first things first, let's go ahead and validate that user verbal kint is actually here. So we'll do get local, and luckily, since I fat finger everything, I can use tab to complete within PowerShell for the cmdlets, which is awesome. And here we can see 2 instances of that verbal kint guy. Not great. But let's also take it one step further. And again, just for the sake of me being terrible at typing while live, let's go ahead and copy and paste. And we can showcase you can copy and paste directly in the shell. Super easy. Get item property of the registry key that we looked at before. We can see Kaiser Sose, PowerShell execution policy unrestricted, exactly like we thought. So first things first, let's go ahead and actually change that execution policy. So just to make sure that's not in unrestricted currently, set the execution policy, and then we can do it. Go ahead and do get execution. See, I type wrong every single time, but right there, all signed, which is exactly what we changed it to, which is awesome. So next step here, let's remove that registry key. So again, we're just going to copy and paste in over here, remove item property of the specific Kaiser Sose registry key, and that is all set. So if we go ahead and we just call back and then get the item property, it should no longer be there. Bum-ba-da. And as we see, no result. Perfect. We've deleted the registry key. Good to go. Now, last thing, let's go ahead and check out that script in the hidden recycling bin. So again, I'm going to copy and paste because of the fact that I, for whatever reason, can't spell recycle. But you can see we changed directory into that hidden recycling bin. We'll do ls to enumerate what's in there. We'll see the bad.ps1. And then if we want to see the contents of it before we remove it, we'll do cat, tab to complete again, bad.ps1. And we can see here it's creating a new local user of verbal kint with a password of 123. Very, very sneaky of him. Adding himself to local group members. And then lastly, starting calculator when you spawn your machine. Talk about nefarious. Calculator is going to pop up. Wow. Good thing we caught this one. So what we'll do very simply is we'll go ahead and we'll do remove bad.ps1. And if we ls, we see that it is no longer there. So that's kind of the full cycle. Again, very similar to what we went through on the Linux side, but we utilize the attack mode specifically to get a specific persistence mechanism we're looking for, identified an abnormal registry key that is attempting to recreate this user. So if we just deleted the user, then it would still be able to come back if we didn't remove this registry key, and then ideally delete this bad.ps1 once we ascertained what they were attempting to do. Now we've gone ahead, we've removed the registry key, we've changed back the PowerShell execution policy, which we identified was changed by the script. Then we went ahead and now we can see we removed the script and everything should be all good to go. So that's a brief overview. Again, very simplified use case. Couple other things we want to look into, like how they got there in the first place, but that's for a later video. So hopefully this was helpful, and thanks everyone. Have a great day.